Okay, what we're going to do in this chapter is really dig into limits and how they work and what they look like, and really start applying them to the different types of problems that you're going to see. And so the easiest way to do that is just to dive on in and talk about limits that we've seen 1,000 times before, and those limits are asymptotes. And we've talked about them, and we've looked at them, and we've graphed them, and we've put dotted lines where they should go, but here's what they really are. So the line y equals v is a horizontal asymptote of the graph of a function y equals f of x if either the limit as x approaches infinity of f of x equals v, or the limit as x approaches negative infinity of f of x equals v. In other words, as your graph grows really, really large or goes really, really small, it approaches a specific number. So what we're going to do is use graphs and tables to find the horizontal asymptotes of the following two questions. And I'm going to minimize the notes just a little bit so that we can see the graphs here, and I'll show you a graph and table for each one. And so first off is x over the square root of x squared plus 1. We're going to look at this guy first, and you'll see him right now. And basically, we want to know about the horizontal asymptote of this guy. So as x gets really, 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 really big, what number are we approaching? And it looks like it starts to level off kind of. It's hard to tell, but if you look really close, our graph levels off somewhere around y equals 1. Okay, now it might not ever say 1 in the table of points, and it might not ever say 1 on the graph or look like it. It might look like it, maybe gets closer, maybe doesn't, but it's 1. And then if we go towards negative infinity, by the way, this is when x goes to positive infinity. And then when x goes towards negative infinity, then what we're going to notice is that the y values approach a different number, -1. And so that's a horizontal asymptote. This guy's got two of them. Kind of cool, I know. So anyway, that's what a horizontal asymptote does. You've seen it before. You've done it before. You just get to do it some more. All right. Switching gears now and throwing a trig function in there. We've got sine x over x. Now this is an interesting one for horizontal asymptote. Remember that you can't have 0 in the denominator. So if we graph this guy, remember that we're not interested in what happens at 0. We're interested in infinity, okay? And so we want to know that what happens with this graph as x approaches positive infinity. And what's going to happen is the sign is just going to bounce back and forth between 1 and -1. But the bottom, the denominator, is just growing exponentially. So where does this guy go? This guy's going to go to 0. And the same thing is going to happen when you go to negative infinity. When you've got x approaching negative infinity, and you can see it on the graph and in the table that I'm showing you right now, when x goes to negative infinity, this graph also goes to 0. So what does that mean? That means that for this problem, y equals 0 is a horizontal asymptote.